Hello everyone. Now let's take a closer look at the SDHydroTools and see how we can use it for our application. Basically, we want to get data for our rainfall, for precipitation, which is the focus of this lecture. And most importantly, we want to get the hydrograph information, meaning that we want to see how precipitation depth changes over time, over like each 15 minutes, let's say, of the storm as it progresses. So this is the software that I have shared with you through the course management learning system, Canvas, and you can install it. It's a pretty quick installation, shouldn't take more than a couple minutes, and after that you get the shortcut on your desktop, SDHydroTools. And here in the project, this is where you explain the project information, the recurrence interval, like let's put 100-year for now, and for this example I'm using the campus location, 5500 Campanile Drive, San Diego, California 92182, and here you click on next. This is where ideally you should be able to see the base map, but they're fixing this for now. But you do have the option of checking with the latitude and longitude. So if you have followed the instruction for the USGS stream stats, you can see there is a report for your file, and I'm using SDSU location here, and then I do have the latitude and longitude listed for me. So I copy paste latitude here and longitude here, and then I can verify. So with this, then I'm pretty sure that I'm in the right location and I can get the data here. With get data, it searches all the Atlas 14 shapefile data, and it is presented you in a minute. So right now I have the information for 5-minute, 10-minute, all the way to 24-hour event. And note that includes the built-in data for 100-year recurrence interval. So if you want to use other return periods, then you need to use the Atlas 14 data from the NOAA website and put it here. And once you put something here, as explained in this box, they appear in red boxes. So green boxes are those that are associated with the 100-year event and their built-in data of the software. So now I have the data. This is again just the depth data, right? We do not have the hydrograph information, how each rainfall depth occurs at each hour of a storm or each 10 minutes of it. For that purpose, then I click on next, and then if I need to do any interpolation, like let's say in the previous tab, I need like 45 minutes event, then what's the depth of 100-year 45 minutes, then I can put here 45. And then it is basically an interpolation. It's a log-log interpolation, so you can see this 1.03 is now between the numbers that I had for 30 minutes and 60 minutes. So that's just a basic interpolation. Here, we're not still at that point that we can do the hydrograph estimation, but if we click on next, then the rational method is being employed, so we can do the estimation here. The information requested is time of concentration. Time of concentration, the accurate method is following the SD county manual. This is the section for the rational method, section 3, rational method. But we can do an estimation here. If you want to do the rational method section, then the part on 314 time of concentration, we should proceed that and all the steps for the flow in conduits or in overland, so we can come up with a time of concentration. But for just a quick estimation, we can use the Kirkus formula, which is basically for natural watersheds, but that's a good like first estimate of the equation that we need. And for the Kirkus formula, you can use the stream stats information. Basically for that Kirkus formula, you need the length of the longest flow path that is available to you here, and also the difference in elevation, maximum minus minimum elevation, and you can follow that. So let's say with this information and the Kirkus formula, it gives me something like 20 minutes of time of concentration. And watershed area is available in square miles. You just need to convert it to acres. So basically very quick, I do 0.2 square mile to acres, and it's going to be 128 acres. So I can do 128. The runoff coefficient, that one also you should follow the county manual, and you can also use the information in terms of imperviousness that is available to you through the stream stats. The imperviousness, you can use average percent of impervious, like for this watershed is 66%. This information, in addition to what we have from the county manual here for the runoff coefficient, that is chapter 312 runoff coefficient. So for our area, which has about 66% of imperviousness, we can assume 0.71, because again, assuming soil D is a good guess for San Diego, we can assume 0.71 is our runoff coefficient C for this area. And peak flow rate. The peak flow rate, you can do the rational method calculation, or you can use estimation from stream stats. If you do the rational method, basically it's Q equal to CIA. You can multiply C by the area and also the precipitation depth that you have. So if I do 0.83 times 128 times precipitation, if I do a 100-year event, and we're doing for like 24 hours, let's say, that's gonna be 4.5 almost. And this is for 24 hours. So for intensity, I just need to divide it by 24. That's gonna give me about 20 CFS if I go the rational method. But I can also use the data from stream stats just as a cross validation. And now this is going to give me 45 for 100 year. So that's like a more conservative approach. So I use 45 here, and then I do the calculate. So this is the table I get. This is basically useful for the Q, and I can export this data to Excel to further process it. So I have like 45 as a peak, and I export this, and I save it. So I have already saved it, and that's gonna be my rat hydro Excel for the rational method. And you can see it's giving me, if I plot time in hour against QCFS, you can see it's going to give me a peak flow for about less than 2 hours. And that's going to be a hydrograph based on the rational method. But we're not really using this for stormwater modeling. We do the calculation through the software like SWIM. Basically, in this exercise and this application of the HydroTools, we want to get to the hydrograph information, which in the best accuracy is provided through the nested storm convolution. That's a method of NRCS explained in the chapter 4 of the SD County manual. Basically, I have everything for this. I just need to put the software. Note that this is square mile again, not acres. So my square mile is 0.2, and I want to do the computation of, like, let's say every 15 minutes. So then I have the hydrograph for every 15 minutes, and I have it, and then I can calculate. And if I calculate this, then I can export this again. Export, and I save it. I have already saved this as this Excel. So you can see there are different data set available for me. And in this example, actually, I'm using 15 minutes, but for the Excel, I have it as 10 minutes. But those are, pretty accurate information. So you can basically repeat it. You can do this as 10 minutes now, and then do the calculation. So now it matches with what I have in my Excel. As you can see, if I plot this information, I have different columns. What I have here is incremental hydrograph at the end, and also the cumulative. So the incremental is basically what I need to use for my modeling. That's the key input data for my modeling. I want to see how my precipitation changes, and then I use this for my designing green infrastructure, BMPs, and things like that. And that's the nested storm is for a 24-hour simulation. If you go through the manual, you can see how the nested storm can expand a 6-hour event over 24-hour duration. So that's proper for design and modeling. And we can check things here to make sure we have done them in the right way. If I do the cumulative, then you can see I get over the 24 hours, I get about 4.5 inches of precipitation. So if I go back to my project, I can see and I can validate that and confirm that for a 24-hour event, I have 4.5 inches of precipitation. So then I can make sure that this is the right calculation. And again, for modeling, we need to use this column. We need to use the incremental precipitation, so which is this. So it shows me that the maximum precipitation intensity, like inch per hour information, is this number. And this is all set and ready to go for modeling at this stage. The software also has other tools like SD unit hydrograph, which we don't need to use for modeling. The key outcome of this software is that basically we get data like the total depth, as I explained in the lecture, the totals basically, and total depth basically for 24 hour. And then we can process this through the software to get to the hydrograph. And this is actually saved as, when you save this, the name that it chooses is the hydrograph table. And that's the key outcome of this data processing.